Today we're going to get into a very important idea in the reporting and analysis of scientific data. And this is called using significant figures in mathematical calculations and reporting them. So significant figures at bottom is an idea in scientific data gathering and interpretation that tries to, in a sense, keep the reporting of scientific results honest based on the actual accuracy of those measurements. So before we dive into the rules and all that sort of thing, let me give you a quick example of why this actually makes sense and why it matters. So let's say that we have an experiment. It's an agricultural experiment. We are growing lettuce for, doesn't matter what the dependent or independent variable and all that stuff is. Well, let's just say we have a set of data, a bunch of lettuce plants, and we're in a hurry and every kid needs to have something to do. And the teacher gives out 3 scales and says, y'all divvy up the lettuce and you weigh it out. Let's say our performance data is the mass in grams of the lettuce. Like we're trying to grow nice big lettuce, okay, for, regardless of the method, that was the goal. And the problem here is that each scale measures to a different level of accuracy. So let's say the first scale that the first student gets only measures to 1/10 of a gram, 0.1 of a gram. And the second scale weighs to 100th of a gram, 0.01. And then the third one weighs, is the best of all, it weighs to 1,000th of a gram. And so here we get their data. And as you can see, this set reflects 1/10 of a gram measurement. This set reflects 100th of a gram measurement. This scale represents 1,000th of a gram measurement. So let's say we were trying to get an average. So we would add up this data, and I summed it up here. This is the sum symbol, by the way, in mathematics. It was 1,859.65 grams was the mass, okay? And we take an average by dividing by 24 because that's the number of data points in this set. Now this isn't, the dividing by 24, that's not a data point, that's a pure value. That isn't based on anything that was weighed on the scale. But we get this huge number, 77.485166666 into an infinity, and so what would we round this to? What would be a good point of rounding? Well, in science, you round to your lowest accuracy of data, or your lowest quality of data, if you want to think of it that way. And when we are adding up numbers and we're trying to round, in this case, remember taking an average is just based on adding up numbers and then dividing by the number of the set. In significant figures, the rules is for added and subtracted values, we round to the least number of decimal places, okay? And as we see here, these numbers were only to 1 decimal place, whereas these were to 2 and these were to 3. So we measure to our main level of error, and our error in these numbers are to 1/10. And so you may say, well, Mr. Munger, these are to 100th and these were the 1,000th. Well, unfortunately, they are only part of a large set, and some of that data has a significant error of where we were only able to measure, assuming that all these scales are good scales, to 1/10 of a gram. So science tries to be a little bit humble, because it would certainly make no sense to report this number. We certainly don't have a scale that goes to the millionths of a gram. That would make no sense. And then we also have to acknowledge is that this data is not as high of a quality as this data, and then this data is not as high quality as that. So we kind of round down to the lowest quality of data, which is 1/10 of a gram. So that's what we do. We round to 77.5, which is 1/10 of a gram, which reflects that some of our data was only measured to that level of accuracy. And so as we get into the next videos of what significant figures are and how the rules and how you use them, you need to keep in the back of your mind that the purpose of this is to reflect a certain honesty in reporting of your gathered data, your transformed data, and how it is interpreted. That you acknowledge that not all data necessarily is going to be of the same quality, and that you measure to the lowest quality, the lowest accuracy of the data. And in this case, when we're adding, that means to the least number of decimal points. We will learn that when we're multiplying and dividing, we have a slightly different standard, but the idea, once again, is the same. We are rounding to reflect the least amount of accuracy, not the most, because in a sense, it's more honest.